Hello, Assalamualaikum friends. This is me, your online pharmacist, and you are in online pharmacy. This is our channel logo and this is our name. Please do share and subscribe for support me and my team. So the today's topic is disperse system. What is disperse system? As the name indicates, most of you are aware about disperse. What is disperse? A disperse is the if I want to do it in Urdu, is फैलाव यानी कि फैला हुआ. And system indicates it has a boundary. Example of room is perfectly matches for this system. The room has a boundary, walls, and the things which are present in the room aren't dispersed. Whenever you are bored, you are tired after returning from the college, all the things are dispersed in your room. So what it indicates that फैली हुई होती हैं आपकी सारी चीज़ें. So similarly, the same situation is on dispersed system. It comprising of two things. The first is the boundary or the air inside the room. You can also understand by this. This is the liquid. The liquid is a dispersed medium like the air in the room. And the dispersed phase, the things which are dispersed on your room, same like here, these are molecules. These molecules are in dispersed phase and the liquid is a dispersed or dispersion medium. And the blue molecules indicate this is the dispersed phase. Now come towards how many type of dispersed systems are there, how we can deal with it, what is the importance in pharmacy or as compared to other subjects. The term dispersed system comprising of two, as we have discussed. The first one is a dispersed phase and the second one is dispersion medium. The another name for this dispersion medium liquid is continuous phase or vehicle. Vehicle, you also almost know that what is vehicle. Vehicle is something that can take up more than one or two kinds of things into itself. This is the vehicle. Basically, the dispersed system, it's not only from this equation or from this statement, you cannot be understand that it's only a liquid or a solid. No, we are not talking about only solid and liquids. We are talking about the system. The system may have gas, the system may have solid, the system may have semi-solid, and the system may have liquid. So these are the different conditions which can be done, which can be present in when we are dealing with the different pharmaceutical products or in pharmaceutical industries. So it's not a limitation that maybe a liquid or molecules are in dispersed phase. The dispersed system is comprising of following types. These are the subclasses of this dispersed system, that they may exist as a coarse dispersion, which we have discussed on later inshallah, coarse dispersion. The second one is colloidal dispersion and the third one is true solutions. As you are much known away about solution, the true solutions are those in which the molecular dispersion is present. Means the molecules are dispersed in a solution. You cannot see because true solution is only a single phase system. The second one is colloidal dispersion. Colloidal dispersion means the particle size of the dispersed phase. What is dispersed phase? The thing which is dispersed inside the system, having a size of 1 nanometer to 1 micrometer. And the third one is coarse dispersion, means a particle have a size greater than 1 micrometer. So you can say that this is the coarse dispersion. Why? Because it has the particle size, the molecule size inside the system is greater than 1 micrometer. And the third class is coarse dispersion. What is coarse dispersion? They are of two types: suspensions, emulsions. Coarse dispersions are of two types. Number one is suspension. First of all, we are dealing with suspension in this lecture, and on the next lecture later on, we are talking about emulsions, types of emulsions, and many more. What is suspension? As we all know that suspension is a coarse dispersion. Why we are saying that it's a coarse dispersion? Because it contains two phases, a dispersed phase and a dispersion medium. Example, ibuprofen, the most common drug in our homes, over-the-counter drug. Why we are saying that it's an over-the-counter drug? Because these are present without any prescription. Okay, so pharmaceutical suspension is a coarse dispersion in which insoluble solid particles are dispersed in a liquid medium. This liquid medium is a dispersion medium. Some of the particles are observed under the microscope to exhibit Brownian movement. If the dispersion has a low viscosity, if these dispersion have the low viscosity, why we are saying that it has low viscosity? If these are two factors, low viscosity and high viscosity, it may going to affect the system of the dispersion system, colloidal system. These molecules are on standing in a liquid. Why? What is the reason behind this? The reason is Brownian movement. Due to Brownian movement, they are present still standing in a liquid. So they exhibit a Brownian movement. And what is the Brownian movement? We discussed on it later. What is the example? Example of oral suspension, oral antibiotic syrup, which normally contain 125 to 500 milligrams per 5 ml. You must have to ensure that suspensions contain 125 to 500 milligrams per 5 ml of solid materials. Okay. So when suspension is formulated, according to given pharmacopoeia, they must contain 125 to 500 milligrams per 5 ml. Mean 5 ml of liquid contain 125 to 500 milligrams of which of dispersed particle or solid material. When we are using, suppose when we are preparing a pediatric drops, so concentration is different. When we are preparing a dermatological preparations, then this concentration is different. So this is different according to the type of usage, according to the therapeutic effect, according to bioavailability, and according to absorption. So when we are formulated pediatric drops, the concentration of suspended particle is correspondingly greater in pediatric drops. Antacids and radiopathology. What is the radiopathy? Radiopathy. Basically, a radiopathy is what is radiopathy? This is also a type of colloid. Is that also a type of suspension in which the dense structures are present or the particles having a dense structure are present. What these particles do? These particles, if we are doing an X-ray of that suspension of that system, then they resist the path of X-rays and cannot allow the X-ray beam, X-ray light to pass or cross them. So there's a no pattern observed for that. What are suspensions? Suspensions are greatly high, generally contain a high concentration of dispersed solids. Suspensions, as the name indicates, suspension, they contain a large or a greater amount or greater concentration of dispersed solids. What is the application of this term, this system? Why it is so important? Why we are studying in this? Because whenever we applied suspension for topical use, our legions and are designed for dermatological, cosmetic, and protective purposes. What these dispersed particles do in our suspensions, in our preparations, these particles, whenever you are applying it on your hand, they form a layer of which? Layer of particles which when they are not allowing the X-ray to pass, so how they can allow the ultraviolet lights or sun rays to pass through or affect your skin? So this is important in dermatological preparations, because why we are applying dermatological preparation? To protect our skin. Why we are applying cosmetic preparations? To enhance our look basically, but for the main purposes, sunscreens, sun blocking agents. These are also having an application of colloidal system. And the another one is the protective purpose. To protect, this is the symbol that sunlight. It provides a barrier that sunlight doesn't cross it and you cannot affected by that light which is coming from sunlight, ultraviolet light, UVBM light or UVB light. All types of rays cannot be going to affect you. The concentration of dispersed phase may exceed 20%. Yes, of course, because we are dealing with a coarse. The higher the amount of dispersed particle, means the solid particles as present in green dots. These are the dispersed particles. As the concentration of dispersed particle increases, the system is going to be stabilized, going towards stability. They provide more protection, they provide more good coverage, they provide a more protective layer to you for your dermatological preparations, for your skin preparations, for your cosmetics and etc. So this concentration may exceed to 20%, not more than 20%. Remember, may exceed only 20%. So whenever using or dealing with parenteral suspensions, it contains 0.5 to 30% of solid particles. These solid particles, if are going to be increased, then parenteral suspensions are going to provide a resistance or a hindrance in a flow, because we are going it parenteral. Doing to in rejected, they are parenteral suspensions. What is the viscosity? Yes, viscosity is another important factor. Whenever, if suppose this is a solution, it contains a liquid. If this liquid is having a high viscosity, so what is going to be happen? Suppose you have a bowl full of ketchup. Whenever you're throwing a ball in it, a plastic ball, it stuck on its surface, not penetrate down at the bottom of the bowl. No. Why? Because the ketchup has a thick viscosity. So it doesn't allow that dispersed phase, that which is ball in that case, not allow it to penetrate and not allow to cross the ketchup and fill or settle down at the bottom. So this is the positive point. This is the advantage of viscosity, that it does not settle the particles. Why we are worrying about settling of particle? Why? We will later on discuss it. Because we don't need suspension settling, we don't need colloidal aggregation, we don't need that these dispersed particles form aggregate, form a lump below the bottom or form a cake at the bottom line. So how we can prevent this? this by increasing or decreasing viscosity. When we are increasing the velocity of this system, this liquid, the particles which are present in this are not going to be are not going to be easily settled down at the bottom. Why? Because there is a resistance or there is a hindrance in the flow. Which type of flow? Because viscosity is what? Viscosity is the resistance or hindrance to flow. So similarly, the particles cannot settle down easily at the bottom, or with the time, maybe it can with time, but we required it is a good storage condition, good optimum condition. If we required a long time storage of our product of our formulation, so we have to increase the viscosity of that medium, of that dispersion medium, continuous phase or a vehicle, so that our particles are not settled immediately. What are the desirable qualities of that suspension? An acceptable suspension possesses desirable qualities including. What are these qualities? Let me point out. The suspended material should not be settled rapidly. Yes, as we discussed earlier. This is a solution in which a single phase exists. You convert it into suspension by adding a dispersed particle. These green liquids are dispersed particles. These particles are settling down at the bottom and causing a precipitation or a cake. It may be of following type. It may be cake. If it's cake formation occur, then it's not a stable product. Why? Because when the patient is going to use the suspension, suppose it's a syrup in which a suspension product is present. So when it taken the active pharmaceutical ingredient or the therapeutic agent, maybe the chances that it can settle at the bottom, so the patient cannot achieve its desired therapeutic effect. So this is not required in pharmaceutical preparation, that it forming a hard cake or flock type material which is difficult to redispersed. The particles do not settle at the bottom of container. So it is the first quality of suspension. What is the quality of suspension? That the particles do not settle at the bottom. Now we can say that it is a stable suspension suitable for our usage, and it's a good pharmaceutical preparation. And not form a hard cake, as we discussed. These are two systems. They both are suspensions. The one is deflocculated and the one is flocculated. What is the difference between them? The flocculated system, the dispersed particles settle down at the bottom and forming a cake. They are very close to each other, means the intermolecular force of attraction is very high in between them, so they form a cake. This is a stable cake, but we don't need this. We need a flocculated one. Why we need this? Because in this the particles are apart from each other, having a gap between them. This white space is a gap between, and this blue is the dispersed particle. So whenever we are going to use this, there's a difference in both behavior. When you shake the deflocculated, it requires a higher amount of energy, or maybe if the cake is hard, it cannot redispersed again, so it is impossible to redisperse that at the time of usage. And as compared to deflocculated, in flocculated, the dispersed particles are very loosely bound to each other. Only a one vigorous shake is required to spread or disperse the particles in a medium. So it can again convert it into which form? Suspension form, which is a suitable form, which is a stable form for our desired usage, which give us a therapeutic effect in which all the particles are uniformly distributed throughout the system. So we need this. This is another quality of suspension. When we are preparing suspension, we have to mind these qualities, these attributes. And the another one, the suspension may not have the too much viscosity. Viscosity is good, yes, as we discussed. Whenever we are increasing viscosity, the sedimentation rate, means the settling of dispersed particles, reduces. But if you decrease it too much, settling, if you want the settling cannot be occur as higher rate, you can increase the viscosity, but you cannot exceed the viscosity from its limit, as it is also given in a pharmacopoeia. What is pharmacopoeia? Pharmacopoeia is a published or standardized books which contain all the information about the pharmaceutical dosages, preparations. Okay, understand? So whenever you are going to increase the viscosity, you must have to consider that whenever you are going to syringe it out, it is not very much harder than to flow it out of the syringe, because if it is too viscous, then the syringe is not able to get it out of the syringe. Okay, so this is another disadvantage of this viscosity. So you must have to consider that viscosity is not too much that it can hinder the flow. It can hinder if you are going to give parenteral, so too much viscosity cause a bolus in your IVs, in your veins, in your arteries, and causing this infusion may it cause an air lump in your vein, which causing a thrombosis, which causing heart attack, which causing a different arrhythmias which are responsible for these air lump. In the case of the external lotion, suppose you are going to prepare a suspension or lotion, you must have to check that the lotion is not too much runny, too much fluidity, that it can run out from your hand. Let's check this example. This is a perfect consistency lotion. It cannot run it down, it cannot move here and there. Its viscosity is perfect, nearly perfect. So you have to prepare that type of preparations which having a viscosity, normal viscosity, standard viscosity, not too much runny, not too much fluidity is the flow behavior, not too much flow of that liquid, that it can cause a messy behavior, it can cause. So it must have a quick dry time. The viscosity is not too much that it cannot quickly dry, and provide an elastic protective film. It's not too much thick that it can rub off easily. So this is the desirable attitudes which when we are formulating the suspension, we have to consider all of these now. The viscosity also has their positive points, also have their negative points. We have to consider that which formulation we are going to use and what is the use of that and for what purpose we are doing this or where we are making this formulation. So it is important characteristic of the dispersed phase. So when you are choosing a suspension, it must have optimum physical stability, chemical stability, and pharmacological properties. So whenever the particle size distribution, specific area, inhibition of crystal growth, and changes in polymorphic forms are of special consideration in formulators. Suppose what we are saying in this statement is special considerations. What are special considerations? Whenever you are on storage, it cannot form crystals. Change in polymorphic form. Polymorphic forms are what forms? That have the same molecular formula but different structures. So they also have a therapeutic efficacy. Maybe the polymorphic form has a less efficacy, maybe the form which is converted into another polymorphic form have the higher efficacy. So we must have to consider that what we are going to use for this. For enhancing viscosity, the another important agent is a stabilizer. What is stabilizer do? As the name indicates, the stabilizer gives the stability to that suspension, so it cannot flow off of the surface. Finally, it is desirable that product contain readily obtainable ingredients that can be incorporated into the mixture and relative easy by the use of standard methods and equipment. So you must have to ensure that the viscosity is not too much high that it will produce hindrance in your creation of formulation, in mixing, in another ointments forms, or in other pharmaceutical dosages. For pharmaceutical physical stability, yes, now we are again come towards the physical stability. What is physical stability? That these particles do not aggregate, do not form a lump, do not settle down at the bottom on standing, because we are going to pack these preparations, we are going to product these preparations, we are going to stabilize. We have how we can stabilize. These are the two methods, that by increasing the viscosity, but viscosity also have a negative effect, and the second one is by adding a stabilizer which gives it a stability, so the particles cannot settle down at the bottom, and it provides a stable suspension which is good for usage, which have a normal behavior of flow, which have APIs equally distributed throughout the system. So these are the important attributes of solutions. Not for solution, basically it is for suspension, because we are talking about suspensions. It is a colloidal system. Ideally the suspension should be thixotropic. What is thixotropic? Thixotropic is a property. Let's suppose example, you having a bottle or mayonnaise in a ketchup. When you are vigorous shake, you may observe that this viscosity is going to decrease after some time. Why? Because when you are applying a force, this force is shear. When you are applying a force with that bottle, its viscosity is going to decrease. But on withdrawal, when you put this bottle on a table or on something where on rest, the viscosity is again obtained by the ketchup, by the mayonnaise. Okay, now this is the graphical representation of thixotropic. What happens at stress 0 means the force over time. When the force is 0, the viscosity of ketchup, suppose of that substance or a ketchup, is at its maximum. But as the time gradually goes on, the viscosity of a substance start decreasing. Why? Because the stress applied is increasing. On x-axis there is a stress is on x-axis and viscosity is on y-axis. The stress is going to increase, so viscosity is going down and causing a thixotropic effect, that's on providing stress, on providing force, on agitation, it decreases its viscosity. But on standing, when stress is 0, at this point when stress is 0, the viscosity is at maximum level. Why the settling in suspensions occur? Also, this is one aspect of physical stability in pharmaceutical suspension, that with keeping the particles uniformly distributed throughout the dispersion. Although it is seldom possible to prevent settling completely over a prolonged period of time, it is necessary to consider the factors that influence the velocity of sedimentation. So, what are these factors which influence the sedimentation? So, we can come towards the theory of sedimentation, which can explain how the sedimentation occur, how we can prevent the sedimentation, and what is the behavior of sedimentation behind this. So the velocity of sedimentation is expressed by Stokes law. What is the velocity? Velocity is the speed, that from which speed the sedimentation is occurring in a suspension. So this speed can be calculated by Stokes law. What is Stokes law defined? This is the relation of Stokes law. V is equals to d square over density of S minus density naught over 80 in at naught. What is rho s, what is rho naught, what is d square, and what is n naught? This v is the terminal velocity. That's velocity and in centimeter per second. Here's d. D is the diameter of the particle in centimeter. Particle of what? The dispersed particle, which is indicated as the blue dots in a liquid. The rho s and the rho naught are the densities of dispersed phase and dispersion medium. What is the dispersed phase? These particles are dispersed phase. And the rho naught is the dispersion medium relatively. So g is the gravity and the acceleration due to gravity. Gravity is also important factor because gravity pulling downwards. So down when we dragging downward, the particles or the molecules dragging towards settling at the bottom. And n naught is the viscosity of the dispersion medium in poise. So what is the application of Stokes law? Stokes law is applicable to dilute pharmaceutical suspensions containing less than 2 grams per 100 ml of 100 ml of solid, exhibiting hindered settling, exhibit hindered settling. So generally it is applicable on dilute pharmaceutical suspensions containing less than 2 gram of solids per 100 ml. What are these dilute pharmaceutical suspensions? A suspension in which a 2 gram of solids mean a 2 gram of dispersed particle in per 100 ml of ml. Suppose it is a beaker, it contains 100 ml of liquid, and in this only 2 grams of these dispersed particles are present in that. So according to Stokes law, this equation is valid only for dilute pharmaceutical suspensions which fulfill this requirement, that is 2 gram of solid per 100 ml of solution, 100 ml of phase. In dilute suspension, the particles do not interfere with each other. Why? Because they are apart from each other. But as the viscosity decreases, they start settling. As the intermolecular force of attraction between them is very weak because they are diluted suspension, so settling may also be prevented by this. So they hindered settling by exhibiting this behavior because they are apart from each other. Free settling occur in pharmaceutical suspensions that contain a dispersed particle in concentration of 5% to 10% or higher percentages. So these particles mostly exhibit hindered settling. What are the changes in rate of sedimentation? According to Stokes law, the rate of sedimentation of particle in suspension may be reduced by decreasing the particle size, provided the particles are deflocculated. When this is the system, coarse dispersion or the coarse system, in which the two phases are present. The first one, which is invisible, is a dispersion medium, and the particles are dispersed medium or dispersed phase. These are the small particles. I am reducing the size of particles. Why? To achieve a good or desirable change, or to obtain a sedimentation, or to obtain a stable product. These are in suspension. Stokes law of sedimentation may be reduced by decreasing particle size, provided that particles are deflocculated. It cannot achieve by only increasing or decreasing the size, but it also viscosity is another important factor. The rate of sedimentation can also decrease by increasing the viscosity. Suppose you are going to even ketchup in a bowl, and the particles of the plastic ball is a particle or dispersed medium. It cannot penetrate down. Why? Because the viscosity is much higher as compared to solution, as compared to simple liquid, because the viscosity of the dispersion medium is very high. So it also prevents settling. So by decreasing the particle size, you prevent settling. So by increasing the viscosity of the dispersion medium, you prevent settling. By addition of suspending agents, as we discuss later, as we discussed in earlier topic, by addition of suspending agent, thickening agents. What are these agents? They provide thickness to the system. By addition of suspending agents, however, there is an optimum level up to viscosity of dispersed medium can be increased, since too much increase in viscosity may hinder the uniform dispersion. If you are going to increase the too much viscosity, the particles, suppose if you are having a system in which it is at maximum viscosity, so these particles cannot redisperse easily. Why? Because there is a greater resistance to flow, and they cannot equally distribute it throughout the system. But this approach is seldom possible because the density is another important factor. By increasing the density of particle, usually the dispersed particle having a higher density as compared to liquid. These particles are going to be settling if the greater density is present. So these are settling at the bottom. Why this settling is not occur in some suspensions? Because of the Brownian movement. Brownian movement is a zigzag motion or zigzag flow. By increasing the density, if you are increasing the density is too much high of the particle, then it settles at the bottom. And so you can prevent the settling may also prevent by when you are increasing the dispersion medium viscosity. But this viscosity, if too much increases, then it also produces hindrance. So we have to create an environment in which the dispersion may be easily. What is the role of Brownian movement in all of these sum up of these equation of the sum up of these law, these of sedimentation, this movement? For the sedimentation, another important factor is the Brownian movement. That why these particles are still standing in a liquid without any sedimentation, because the important factor is Brownian movement. Particles of diameter of 2 to 5 micrometer. Okay, particle diameter is 2 to 5 micrometer on the density of particle and the density and viscosity of the suspending medium. So Brownian movement depend करती है particle size पे. What is the particle size? It's of 2 to 5 micrometer. Then it may exhibit the Brownian movement, and it counteracts the sedimentation to the measurable extent at room temperature by keeping the dispersed medium in a random motion. This is the expression of random motion. There's a zigzag movement of the particles in a system. The system contains the two phases. The first one is the dispersion phase, and the first one is the dispersion medium, and the second one is the continuous phase or a dispersed phase. So that's all for today. Thank you so much. Thanks for listening and watching.